Okay. Assume that randomly selected subject is given a bone density test. So we are given a bone density test. Okay. Those test scores are normally distributed. So we have normal distribution. And mean is equal 0. In normal distribution, z-score always equals 0. And standard deviation, we write down STD as a standard deviation, is equal 1. Find the probability for the given z-score is greater than negative 2.16 and less than 3.77. Okay, how it would look like if we would to draw this on the graph, this normal distribution. So it would look like the following. So this is mean, right? 0. Now, what do we have here? Negative 2.16, it's going to go very far because total it can be negative 3.49. And less than 3.77, which is going to be much higher. Here. It's going to go all the way to here. So it's negative 2.16, 3.77. And we will shade it. Okay, like that. So let's find the probability. So what we are going to do, how much it's going to be equal? Probability for z-score is less equal negative 2.16 is equal, so negative 2.16, so taking negative 2.1, right? Oh no, here it is, 2.1 and 6. We are going to go down all the way to 6. Let me come down. Oh, here it is. Zero 0.0154. 0.0154. And then probability for z-score less equal 3.77. That is equal. We go to positive. 377, so we need to start with 37. Well, the last one obviously is 3.49. As I said, it's running from negative 3.49 to positive 3.49. And the last one, 3.49, is 0.9998. So behind of that, everything is going to be 0.9999. Therefore, probability for z-score that is greater equal negative 2.16 less equal z-score less equal 3.77. That's going to be equal 0.9999 minus 0.0154. And that is equal 0.9845. Question number 2. Assume that random variable x is normally distributed with the mu is equal 84, standard deviation is equal 4. So we need to find probability for x is less than 82. Okay, so to find probability, that is clear that we are going to deal with table, correct? Now, what we know that x doesn't have access to table, only z-score. Only z-score has access to the table. Therefore, we need to transform our x to z-score. How we are going to transform? The formula for z-score is equal x minus mu divided by sigma. X is 82 minus mu is 84 and divided by sigma is 4. And I have no idea why I continued with red color. Okay, so this is equal, what do we get? Negative 2 over 4, and we get negative 1/2, which is decimal negative 0.5. Okay, let's find negative 0.5. So negative 0.5 is going to be, because it's a 0, so the first decimal is going to be 0. I mean, second decimal is going to be 0. Therefore, we are looking at 0 here, and 0.3085. So probability for z-score less equal 0.5 is equal 0.3085. Question number 3. All right. The times per week a student uses lab computer are normally distributed with a mean is equal 6.6 hours, standard deviation 1.2 hours. A student is randomly selected. Find the following probabilities. Okay, so let me read one more time. The times per week a student uses a lab computer which is normally distributed with a mean of 6.6 hours and standard deviation 1.2 hours. Okay? A student is randomly selected. Find the following probabilities. A. Find the probability that student uses a lab computer less than 4 hours per week. X is less than 4 hours. Why we don't use z-score? Because it doesn't say z-score. It says find the probability that the student uses. So X is our student, right? We don't know the probability of student less than 4. That's what it's asking. That student uses lab for less than 4 hours a week. Next, find the probability B that student uses lab computer between 6 and 8 hours a week, which means probability 6 and 8 hours per week. And C, find the probability that the student uses a lab computer more than 9 hours per week. More than 9 hours. There we go. Okay, let's start working. So to remind you, z-score, we need to get from x, right? From our x, we need to convert to z-score. Why? Because only z-score has access to probability, percentage. And because it's given x only, so we need to convert to z-score. So it's going to be equal, z-score is equal x minus mu over sigma. Let's go. Question number one, question A. So before we do any x, we need to find the z-score. So z-score is equal, my x is 4. 4 minus average is 6.6. So average in standard deviation is going to be the same. Only x is going to change, right? So what do we have? 4 minus 6.6, that is equal negative 2.6, and divided by 1.2, we are getting negative 2.1, rounding up because it's going to be 6666, then we are rounding till negative 2.17. Okay, so once we have probability of z-score equal negative 2.17, then we can say probability of x less than 4. It's going to be represented by probability of z-score that is matching to negative 2.17, right? And that is equal, let's find z-score for negative 2.17. Okay. So let me change this color, I have enough. Okay, this one. So negative 2.1, where is my negative 2.1? Right here. And I'm going to go, oh, it's covering numbers, I don't like it. Let me see. Oh, I make it, there we go, this is much better, transparent. Okay. So clean it, go over one more time. All right, perfect. So 2.1 and we need 7. Where is our 6, 7? There we go. And it's coming all the way to here, which is going to be 0.0150. Okay. So that is going to be our answer, which means that's going to be 0.015. That's a 1.15%, right? Okay. Next, B. We need probability for x between 6 and 8, which means what we're going to do, first we take probability for x less equal 6. Then we take probability for x less equal 8. And then we'll find out probability for 6x greater equal 6 less equal 8. Okay? So, this is going to be equal. So, z-score here is equal 6 minus 6.6 because the average and sigma is the same. So, and divided by, how much is it? 1.2. So we are getting 0.6, negative 0.6 over 1.2. And result is going to be 0.6 divided by 1.2. And we are getting 0.5, negative 0.5. All right. Next. So z-score negative 0.5. Let me clean this mess. Negative 0.5. There we go. Since only 0.5, that's mean we take first number, which is here 0.50, right? Here. Okay. So the answer is 0.3085. 0.3085. Less equal 8. So this score for 8 is going to be equal 8 minus 6.6 and divided 1.2. That is equal. So 8 minus 6.6, it should be 1.4. Okay, divided by 1.2, meaning 14 divided by 12. And we get 1.17. 1.17, and we get it positive. So 1.17, we're moving to positive. Here it is. (1.1). And now we need to go all the way where 7 is. 7 is going to be 2 columns till the end, because the last one is a column 9, so 7 gonna be 2 columns before. So this one is gonna be 8790. Okay, let's check it. Yes, indeed. So 80.8790. So which means the probability between them is going to be (0.8790 minus 0.3085 is going to be 0.8790 minus 0.3085 is equal 0.5705. All right. Five, 9 minus, wait a minute. I don't think it's coming out. Hold on. 8, 7, I punched on calculator, but let me double check. 0.3085. This is going to be 5. Oh, yeah, 0. Okay, 7. Here is 5. 5705, which means if you round it, you get 0.571, right? Or 0.57. Okay. Question number C. So what is question number C? X greater than 9, all right? Probability for X greater than 9. So remember, once we find probability that is less than 9, we will subtract from 1, right? because it has greater right tail. Okay, well, it looks ugly. Assuming this is normal distribution. If this is 9, it says more than 9, which means we are going to look for this area greater than, right? Okay, so first of all, let's convert to z-score. Z-score is equal 9 minus mu is 6.6, standard deviation 1.2, and we get 9 minus 6.6 is equal to 2.4 divided by 1.2. If you punch numbers on calculator, you can't go in one line 9 minus 6.6 and divide by 1.2. You will get completely messed up. Why? Because if you do like that, 9 minus 6.6 and divide by 1.2, what's going to happen? First, we'll do calculator, we'll do this division as a first operation, and then we'll do subtraction. Therefore, what you want to do, once you do 9 minus 6.6, click enter so you will see how much is equal. And only then, once you get 2.4, then only then you divide by 1.2. We understand? It's very important because it's an order of operation. So, and we get is positive 2. So now let's find probability for x is greater than 9. Let me find less than 9 first. Is equal probability for z-score less than 2 because it's matching. The z-score represents that x. Let's find where is positive 2. Z-score equal 2. Right here. 2.0. 0.9772. 0.9772. Okay, after that, now we have to do 1 minus, okay, probability for x is greater than 9. It's going to be equal 1 minus probability for x less than 9, or we can put equal sign, doesn't matter. When it have less, you can always put equal with it, which is equal also. Now we convert into z-score. Z-score less equal, okay, I put here equal also. Either way. So that's going to be 1 minus 0.9772, which is equal 0.9772. Let me see. 8.2 0 point and 0.0228, which is going to be, if we round till 3 decimals, it's going to be 0.023 because we are rounding. Okay? All right, we got it. Moving to next question, number 4. Question number 4. Use the normal distribution of fish lengths for which the mean is 10 inches. We are measuring the fish length. Average is equal, average of fish is equal 10 inches. Okay? Standard deviation 4 inches. assume the variable x is normally distributed. So we have normal distribution, which means we can use z-score. All right. So sigma equal 4 inches. Now we need to find how many percent, which is probability, percent of the fish are longer than 13 inches. So length of x is greater than 13 inches. And B, we need to find probability for length of fish are randomly chosen about how many expect to be shorter than x. So which means x shorter than 6 inches. It says shorter, okay, then we don't put equal sign because it's asking shorter, less than 6 inches. And that is for 400 fishes. Okay, let's start A. So z-score we already know, x minus mu over sigma, x is 13, minus mu is 10, over sigma is 4, it's going to be 3 over 4, it's going to be 0.75, right? Okay, so if I find probability for z-score that is less than 0.75, that means we are finding probability for x that is less than 13, but we need greater than 13. What do we have to do? Correct. Once we find probability, we subtract from 1. Okay, so 0.75, our z-score. All right, 0.75. Here, 0.7, and we are moving to 5. Right here. And this is 0.7734. 0.7734. So then, probability for x is greater than 13 is equal 1 minus probability for x less than 13, which is same thing, is equal probability 1 minus probability of z-score is less than 0.75. So the answer is 1 minus 0.7734. And it is going to be, let me see, 1 minus 0.7734. We get 0.2266. Okay. Which means, because it's asking in the format of percentage, that is going to be equal. We move by 2 positions because multiplying by 100, right? 2 zeros, 2 positions. We're going to get 22 point, how many decimal it wants? 2 decimals, 66%. Okay, that's A. Now moving to B. B, we need to find probability for x less than 6. For 400, we have 400 fishes. So probability for x less than 6 is going to be equal probability for z-score that is less than. Let's find out how much it's going to be less than. So x is 6 minus our probability, the average is 10. right? And standard deviation is 4. So minus 10 and divided by 4. Negative 1. So let's get negative 1, how much it will be. Where is my negative 1? Uh, 1.0, it's right here, which is going to be 0.1587. So here less than negative 1, and this is equal 0.1587, and this is our answer. For one fish, actually, for one fish. But we have 400 fishes, which means for 400 fishes, percentage is going to be, we have 400 times 0.1587. That is equal 63.48, which means we expect approximately, okay, 63. In this case, I got 64 if I round it up, so I'm not getting half of the fish, so it's going to be 64. We expect approximately 64 fishes to be shorter than 6 inches. Okay, question number 5. Okay, question number 5. So assume that random variable x is normally distributed with the mean is equal 50, standard deviation is equal 7, and we need to find the probability for x is greater than 41. Okay, so first of all, probability for x is greater 41 will be represented by probability of z-score, which will convert 41 to, we'll see what it's going to be. So to convert it, so right now I leave it like that, and let me find the z-score. Z-score is equal x minus mu over sigma. X is equal 41 minus mu is 50 over sigma is 7. So it's equal, let's see, 9 divided by 7, 1.29, negative 1.29. Okay. So from here, probability for x less than 41, because we need to find how much less than first, right? Is equal probability for z-score is less than negative 1.29. So less than 29, where is 29? Negative 1.2 here, and from here we are going all the way to the end. 0.0985. So is equal 0.0985. So which means probability for x greater than 41, it's going to be equal 1 minus probability for z-score less than negative 1.29, because we found information if this is x is equal 41 greater than, that's the same thing. Oh, 41 is going to be other way because it's less than mean. Okay, let me explain. Look here, my mean is 50 and my x is 41. It's below, right? If below average. So if my x is 50, which is here, x is equal 50, that's average, then 41 it's going to be somewhere here, right? X is equal 41, right? And accordingly, x is equal 41, z-score is equal negative 1.29. Let me write down clear. X is equal 41. So we need to find this greater than 41, which means we have to find this area. So therefore, first I'm finding the area that is below this one, right, the green one, which is 0.0985, right, because I found here less than. And then what I'm doing, I'm subtracting from 1 to get this yellow one. So this is 0.0985. This one is going to be 1 minus 0.0985. And probability for x is greater than 41, which is going to be equal probability for z-score is greater than negative 1.29, right? That's going to be equal 1 minus 0.0985. Okay? 1 minus 0.0985, and that is equal 0.9015. Okay, so this is question number 5. Now moving to question number 6. What do we have? We are given average is 88. Standard deviation is 4. So find the indicated probability, and probability is x is greater than 75 and less than 84. So what do we need to do? First we need to find probability x is less than 75, and then find the probability x is less than 84. Okay, so to find it, z-score is equal 75 minus 84 over standard deviation is, minus 88. Average is 88, and divided by 4. Standard deviation is 4. So 75 minus 88, it's going to be negative 13 over 4. And 13 divided by 4 is equal 3.25. Negative 3.25. Okay, so probability x is less than 75 is equal probability for z-score is less than negative 3.25. how much is it? Let me move this. This is going to be 3.25. Here it is. 2.5, which is coming here. This is 2, this is 3. So it's gonna be here in the middle. Okay, 0.0006. So, okay, well, the middle also gonna be 0.0006. Yes? Okay. Let me move this score calculation a little bit further. Okay, at least this far, so we can see our calculation. Let me make it more compact. Okay, that's not what I meant. It's running wherever it wants. There we go. Now let's find x is less than 84, which means this score is going to be equal. X is 84 minus 88 over 4. So we get negative 4 over 4 is equal negative 1. So it's equal, probability for this score is less than negative 1. And that is, how much is my negative 1? There we go, negative 1. It's right here, 0.1587. All right, so which means probability for x is greater than 75 and less than 84, it's going to be equal 0.1587 minus 0.0006. Which is going to be equal. So 7 minus 6 is 1. Here it's going to be 8 minus 0 is 8. 5 minus 0 is 5. 1 minus 0 is 1. 0.1581. All right. Moving to question number 7. So what do we have? In a recent study on world happiness, okay, we're dealing with world happiness. Participants were asked to evaluate their current lives on a scale from 0 to 10. Wow, they are evaluating the dangerous thing. When 0 represents the worst possible life and 10 represent the best possible life. The responses were normally distributed with the mean is equal 4.5, standard deviation is equal to 0.4. So let's go question A through D. A. Find the probability for participant response was less than 4. Probability for x less than 4. Okay, for less than 4, we have Z-score is equal 4 minus 4.5, which is mu, divided by sigma, which is 2.4. Okay. This is equal negative 0.5 over 2.4. So we have to take practically 5 divided by 24. And it's going to be negative 0.21. Okay, next, probability for z-score less than negative 0.21 is equal, which is same thing, probability for x is less than 4, right? So that is equal 0.21, 0.2, here it is, 0.2, and this is going to be my 1. Because this is going to be 1. Let me go up all the way. Yes, it's 1. So this one is going to be 0.4168. For 168. Negative 0.21 for 168. Okay. Four decimals. All right. Next. B. So we need to find probability for x that is greater than 4, less than 6. Question number 8. In the recent year, the score for the reading portion of the test is normally distributed. Let me fix it. It's supposed to be normally distributed. It's normally distributed with mean 20.9 and standard deviation of 6.1. So let me write down mean 20.9 and standard deviation is 6.1. Okay, find the probability that randomly selected high school student who took the reading portion of the test has a score that is less than 19. So x is less than 19. So what do we do here? We use z-score. That is equal z-score, that is equal x minus mu over sigma. Yes? Okay. So from here, we have our x is 19 minus mu, which is 20.9, and divided by sigma, which is 6.1. So let's do it. So 19 minus 20.9, it's negative 1.9, and dividing by 6.1. So we are getting negative 0.31. Okay, so what do we have? Probability for x that is less than 19 is represented by probability of z-score that is less than negative 0.31. And that is equal. let's go to our table, negative 3.31, negative 0.3, here it is, and 1 it's going to be right here. Let me change the color. Okay, blue one. So 0.3 and 1 is coming right here. So we have 0.3783, right? 311. So it's going to be 0.3783. Okay, next, find the probability that random selected high school student who took the reading portion of the test has school portion has a score let me, okay, has score that is between 17.4 and 24.4. Our x is greater than 17.4 and less than 24.4. Okay, so we need to find this score, right? So this score, probability for x that is less than 17.4 is equal, how much? Let's find this score first. X is 17.4 minus average is how much? 20.9, right? Here it is our average, and here is our sigma. So 20.9 and divided by sigma 6.1, and we are getting 17.4 minus 20.9, negative 3.5, and divided by 6.1, we are getting negative 0.57. 0.57. Okay, so probability for x is less than 17.4 is equal probability for this score that is less than negative 0.5. Yes, negative 0.5. Next, how much is probability? Let me move this down, rather saying, let's do these changes. Would be much better. Okay, so this is equal less than negative 0.5. Here it is negative 0.5. It's going to be 0.3085. 0.3085. So next, for probability for x less than 24.4, this one, we need to find that probability for this score that is less than, we'll find out. So this score is equal 24.4 minus 20.9, yes, and divided by 6.1. So that is equal 24.4 minus 20.9 and divided by 6.1. 0.57. Okay, so it's going to be less than 0.57, which is how much? Positive 0.57. Let's see. 0.5, and we need to go all the way till 7. Right here, 7. So 0.7157. 0.7157. This equal sign. Okay, so which means the probability between x between 17.4 and 24.4 is going to be equal then x less than 24.4 is equal 0.7157 minus 0.3085. Let me highlight, and this is for x is less than 24.4. This is for x is less than 17.4, and the answer probability 3085, 0.7157. So when we subtract, we're going to get 7 minus 5 is 2, 15 minus 8 is 7, here is 0, so it's going to be 0, and 7 minus 3 is 4, so it's going to be 0.4072. Okay? C. Find the probability that randomly selected high school student who took the reading portion of the test has a score. Again, it has school. I was dictating under Siri, and Siri is the one messed up. So I'm going to, next time I will read it. Score that is more than, let me write down here. Has a score that is more than 33.1. So we need to find probability for x is greater than 33.1. Okay, so to find the probability for x that is greater than 33.1, that's going to be equal probability for x that is greater than 33.1 is equal 1 minus probability for x is less than 33.1, which means it's going to be equal, okay, let's go step by step. So first we need to find probability for x that is less than 33.1. For that reason, we are going to find z-score first. So z-score is equal. How much is our the z-score? It's going to be x is 33.1 minus, how much is our average? 20.9, and divided by 6.1. It's from here, right? Here. So 20.9, 6.1, mean and standard deviation. Okay, this is going to be equal 33.1 minus 20.9 is equal 12.2, and divided by 6.1 is going to be equal to. So let's go for z-score that is equal to, z-score less than 2, and that is equal. Let's see. This is negative. Where is our positive? Here it is. Two, and since it's only 2.0, which is going to be 0.9772. Okay, so what we have probability for z-score is less than 2. To find probability for x is greater than 33.1, it's going to be is equal 1 minus probability for x that is less than 33.1, and that is equal 1 minus probability for z-score that is less than 2, right? And the result is going to be 1 minus probability z-score less than 2 is minus 0.9772. And result is going to be 8, and then 9 minus 7 is 2, 9 minus 7 is 2. Here is going to be 0.0228. Okay. 0.0228. And the last question, we have one more question to answer, question D. The question is, we need to identify unusual events. What is here unusual? So everything that is less than 5% is considered unusual. Okay? So in this case, let's see. In the case of A, we got 0.3, which is 37.83%. In B, we got 0.4072, that is 40.72%. And this one, we get 2%, which is less than 5%, right? That means the event in C is unusual because probability is less than 5%. 5% is 0.05. Okay, question number 9. Let me push this down. It's number 14. It's far from 14 so far. Moving question number 9. So what do we have? We have the area. So this score is, it's given the area already. What we do know, the area is 0.2810. We need to find what z-score is matching to this area. Okay? So let me write down this way. Probability for z-score, let's equal question mark. Okay? Let me make with the red color, question mark, is equal 0.2810. So what do we have? Before we had z-score, and we would find the area or the probability. Now we're going backwards. We have the probability, and we need to find which z-score is matching. So what do we have to do? We have to find in the area in the body, right here, in the body. This is the body. So we have to find here 0.2810. But here is a question. Am I going to look in the negative or positive z-score table? One thing, remember what I said previously. If we have this is 50%, right? Z-score is 0, low 50%, upper 50%. So this is negative. So which means this area, it's going to be from 0 to 0.5. Low is 50%. Why? The numbers are growing this way, right? So the higher area, this area, it's going to be between 0.5 and 0.5 to 0.99999 or whatever, okay? Because statistics never shows 100%. Now we have 0.2810. It's less than 50%, right? Because it's 28%, which means I'm going to look in the negative z-score area. So I need to zoom so I can find better. So it is gonna be 0.280. So I have 5, 8. Oh, this is positive. Let's go to negative. Cleaning this. So we need 0.2810 to 7. I see here to 7. I need to 8. Let's go find 2.6, 2.5, here 2.29. 8, here it is, here it is, 0.2810. So this is coming to, let's see where it's coming, which z-score it's coming. Negative 0.5. So let's write down, z-score is less equal negative 0.5, and the second decimal, let's go up. So we can find, looks like it's going to be 8. That's right, 8. So negative 0.58. Okay? Next. Question number 10. We have standard normal distribution, okay, with the average here is 0, and we are given the area, this area to the right, and this area is 0.0918. Okay, we need to find the z-score. So, to find the z-score, what we have to do, we need to find, we have to get the area to the left, right? Because it's the table shows area to the left. So this area. How much is going to be this area? It's going to be 1 minus 0.0918. So 1 minus 0.0918, and that is equal, did I write down? Okay, let me do it myself. I don't want to rely on calculator. 0.000. So it's going to be 2, 9 minus 1 is 8, 9 minus 9 is 0, here is 9, here is 0. So it's going to be, this area, it's going to be equal 0.9082. So now we go to the table and find 0.9082, okay? 0.9082, which is 90.82%. And that means we are heading to positive z-score. 9082, where is 9097? Here is 97, here it is. 82. So it's coming where? 1.3. So this score is going to be equal 1.3, and it's going up to 3. Okay. Question number 11. Because this score is the same, right? It's sharing to the area to the right and area to the left, but the thing is, our table shows to the left. That's why to find out z-score, we need to know area to the left. Okay? Next one, question number 11. Okay. Something similar. We are given this area, this score is here. Obviously 0 is here. So it's going to be negative. We already see it, right? Because it's below than 0. And it's the area to the right. And how much is this area? 0.9222. What do we need to do? We need to find the area to the left, because our table shows area to the left, which is going to be this one, right? Tiny bit that's left. Okay, to the left. So we are going to do 1, 2, 3, 4, minus 0.9222. 10 minus 2 is 8, 9 minus 2 is 7, 9 minus 2 is 7, 9 minus 9 is 0, and we get 0.0778, which means this area is 0.0778. Okay, 0.0778, we are going to look in the negative area, correct? So let's go see. 1.4, 0.0778. Oh, here it is. So the z-score is going to be, this one is negative 1.4, and let's go up. See what is going to be. Oh, 2. So negative 1.42. Question number 12. Number 12, we have find the z-score that has 6.3% of the distribution area to the right. This is what I would do. Z-score that has 6.3% to the right, which is, let's say, 6.3%. So 6.3%, that is equal 0.063. So we need to find the area to the left. So that is going to be 1.000 minus 0.063, 0.937. Okay, let's find it, 0.937, which is means we are going to look in the positive area. So 9 is here, this is 9.452, so it will be somewhere here. 9.3, oh, here it is, 9.357, oh, here it is. This is, let me clean this. 0.937, which is going to be 1.5. Z-score is equal 1.5. Let's go vertically up and 1.53. Okay, we have it. 1.53. Question number 13. Find the z-score for which 70% of the distribution area between negative z-score and positive z-score. Okay. So negative z-score, positive z-score, and 70% area that is between them. Okay. How we are going to solve this one? So if this is 70%, which is equal 0.7, how much will be left for these two areas? For this one and this one, it's going to be 1 minus 0.7 is equal 0.3 for these both areas, this and this. So if I divide by 2, right, 0.3 divided by 2, I get 0.15. So this area 0.15 and this area 0.15. So let's go find the area 0.15, which is going to be among negative ones, right? Let's go see. Negative 0.15. Let's find out. Oh, 0.15. Five. We have here 0.1515 and 0.1492. So approximately it's going to be 3, 4. Yeah. So one is going to be negative 1.0. Z-score is going to be negative 1.0, and the second number going in the middle, it's going to be between 3 and 4, 1.035, which if I round it up, it's going to be negative 1.04. Now, because these areas are equal, if areas are equal, 0.15 and this way, and 0.15 this way, right? 0.15, 0.15, that means z-score also gonna be the same. For that reason, if we have one z-score is equal negative 1.4, that means the other z-score is gonna be positive 104, right? This is negative 1.04. This one is positive 1.04. All right. Question number 14. In a survey of women in certain country, age 2029, the mean height was 65.5. So that is mu. With the standard deviation 2.77. Answer the following questions, okay? The heights that represent 95th percentile, so is, okay, 95%. That means, right? It's want to find out, let me show you. %, so 95%, right? So this is 0.95, and we need to find the score. All right, so all we have to do, we need to find z from here, and it's asking the height, it's asking for x. How much is the height? It's asking for x. To get x, we need to get z-score, right? So how much is going to be our z-score? 0.95. Where is my 95? 96, here it is, 96, 95, 94, here it is. We have 94, 95, and 0.9505. So it's going to be 1.6. So the score is equal 1.6, and going up in between 4, 5, which is approximately going to be 1.65 or 645. Doesn't matter. All right. So once we have z-score, we need to find our value of x. So if z-score is equal x minus mu over sigma, so from here, x is equal z sigma plus mu. Yes, we have our z-score, so x is going to be equal. Z-score is 1.65 times our sigma, which is 2.77, and plus our mu, it's going to be 65.5. Okay, and our answer is going to be, let me check, so 1.65 times 2.77 and plus 65.5, and we are getting 70.07, which is approximately, it's going to be equal 70. Okay. Question number B. The height that represent the first quartile. First quartile is 25%, yes? So it's going to be 25%. Let's say this one. So we need to find x, the height. That's mean x is equal question mark. So first we need to find z-score. So 0.25, where we are going to look at where negative z-score is, right? 0.2724. Okay, find here 24, here 2451. So that's approximately what's going to be. No, 24. We need 25. I guess between these two. 25, 0.25 going to be between these two. Or maybe if I take and round this one up. No, it's going to be better, this one. Between these two, it's going to be negative 0.6. And it's going to be between what? 7 and 8. 6, 7, 8. Okay. So x is going to be equal from here. Z-score sigma plus mu. So negative 0.678 times sigma. Where is my sigma? 2.77. And plus mu, average 65.5. 65.5, so let me 277 write down normal. So this one is multiplication sign. Okay. So 0.678 times 2.77, that's going to be 188. Okay, 65.5 minus 1.88, and we are getting 63.62. So this is equal 63.62. Okay. Question number 15. So what do we have? The weight of the bag of baby carrots are normally distributed with a mean 33 ounces. Standard deviation is 0.33 ounces. Bags, by some reason it put banks. It's supposed to be bags. We'll fix it, right? Okay, bags in the upper 4.5%. Gee, it's not going away. Okay. Bags in the upper 4.5% are too heavy and must be repackaged. What is the most bag of baby carrot can weight so it doesn't have to be repackaged? So what we are going to do? So if 4.5% are too heavy and need to be repackaged, that's looks like it's going to be right tail, then which percentage doesn't have to be repackaged? So at 100% minus 4.5%, right? That means 95.5% doesn't have to be repackaged. Yes? So this is how it's going to look like on the graph. So 4.5%, this is the one that need to be repackaged. So which means this one is This one is 95.5%. Okay, so all we have to do, find 0.9555. Yes? So we are heading to positive z-score. Nine five five 9996 9554. Here it is. I would just take 9554 in here, 9564. No, 9554. It would be 17. Let me clear this. Nine five five four. It's gonna go 1.7. So z-score is equal 1.7. Let's write down probability for z-score equal question mark is equal 0.955. So from here z-score is equal 1.7. Okay, now we need to find the amount of bags, which is x question mark. So x is equal z sigma plus mu. So it's equal, z-score is 1.7 times sigma is 0.33 and plus mu. Mu is 33. So it's gonna be 1.7 times 0.33 and plus 33. So we are going to get 33.56. So what does that mean? A bag of baby carrots can weigh at most 33.56 ounces without needing to be repackaged. Okay? All right, I'm done. Thank you for watching, and I'll see you in next recording.